When you look at Earth from space, the defining feature is blue. With oceans covering 71% of the surface, it's easy to assume we have an infinite supply of water to draw from. But to find what we can actually use, we have to subtract the salt. Right away, we lose about 97% of that global volume. That's ocean water, which is unusable for growing crops or basic human survival. We are left with just a 3% sliver of freshwater. We can't easily access most of that either. Roughly 68% of all remaining freshwater is permanently locked away in high-altitude glaciers and polar ice caps. From what remains, another 30% is trapped deep underground. This groundwater sits in aquifers beneath the surface, requiring massive energy and infrastructure to pump out. The final result is consistent across every global model. Less than 1% of the planet's total water exists as easily accessible surface water in our rivers and lakes. That tiny fraction is what sustains all 8 billion people on Earth. Treating water as a limitless resource is a mathematical error. Our entire global civilization, our food systems, our industries, our cities, is precariously balanced on a microscopic fraction of the planet's actual volume. Because we rely so heavily on that fraction, the United Nations is now actively warning of a global water bankruptcy. Over the last 50 years, global freshwater withdrawals have tripled, draining our reserves far faster than natural rainfall can replace them. The human cost of that deficit is already here. Around 4 billion people now experience severe water scarcity for at least part of the year. We saw exactly what this looks like when Cape Town nearly hit day zero. The city's primary reservoirs dropped so low that the municipal water grid came within days of a complete mandatory shutdown. The baseline equation that keeps modern cities running is actively breaking under our current rate of extraction. We're simply pulling more out than the system puts back in. When reservoirs run dry, the instinct is to blame domestic habits, showering, washing dishes, watering lawns. But domestic use barely accounts for 10% of global demand. This chart shows the scale of the imbalance. Global agriculture consumes 70% of all accessible fresh water, dwarfing both the 20% used by industry and our everyday home usage. This agricultural demand is driven primarily by developing nations, alongside major agricultural producers like India, China, and the United States. The industrial sector consumes a 20% share, and its runoff actively degrades what's left. Chemical waste and heavy metals from manufacturing pour into rivers, rendering huge portions of our surface water too toxic to drink or use. Protecting the global supply requires a structural shift in how we farm and manufacture, moving beyond the impact of individual domestic habits. Reforming demand is only half the problem because the supply side of the equation is actively shrinking. Climate change is physically dismantling the Earth's natural water storage systems. High-altitude glaciers act as massive frozen savings accounts that slowly release fresh water into major river systems year-round. As global temperatures rise, these ice reserves are melting prematurely and permanently draining away. Underground, the depletion is just as rapid. Industrial pumps are extracting water from subterranean aquifers long before seasonal rainfall can seep down to recharge the regional water tables. As these natural supplies collapse, water becomes a highly contested border issue. We are already seeing intense friction over who controls the flow of crucial resources like the Nile River. Since water is the primary input for manufacturing, energy cooling, and food production, these local shortages become a global financial threat. By 2050, it is estimated that 46% of total global GDP will face high water risk. To avoid that economic collapse, the global infrastructure requires a complete shift toward a circular water economy. Instead of relying entirely on natural rainfall, we have to manufacture supply. Facilities running reverse osmosis desalination can filter out the salt from ocean water, converting that massive 97% of unusable global saltwater into safe drinking water. We also have to stop using water just once. Singapore has created a successful urban blueprint with their New Water initiative, filtering and recycling municipal wastewater back into an ultra-clean, continuous loop. On the agricultural side, we can reduce that 70% drain by upgrading our field technology. Countries like Israel have proven that adopting precision drip irrigation piping delivers water directly to plant roots, virtually eliminating evaporation and waste. And to protect the grids we already have, engineers are deploying AI systems and satellite mapping to track regional flow, instantly detecting pipeline leaks and system inefficiencies before the water is lost. The days of treating fresh water as an endless natural right are over. To survive this century, we must manage every drop as a carefully engineered and fiercely protected economic asset.